Hey everybody, it's Mr. N here, and we are going to do this practice worksheet on volumes that involve disc washer and cross-sectional areas. So let's go ahead and get started. This first one says find the volume of the solid that results when the region y equals 2 times root x plus 3, y equals 0, x equals 0, and x equals 2 is revolved about the x-axis. So let's go ahead and first graph this and take a look at what we have. So let me set up a quick grid here. And we are bounded by x equals 0 and y equals 0. So we have here and here. And then we've got this equation. Now if you graph this equation, it'll come up over here. When you put in 0, it'll be 2 root 3 somewhere around here. And we will estimate that. And it's got that curvature to it. And the line x equals 2. So we're looking at that region right in here. Alright, so the volume we always know is the integral of the area. And we are going to revolve this about the x-axis, so we need our slices to be perpendicular to that axis of rotation, so we need dx. So in this case, we are just going to have a disk. We only have one curve. We're going about the axis. It's a pretty simple, straightforward situation. We know that the area of a cylinder is pi r squared, and because it's cylindrical in shape, since we're revolving this, and we're taking our slices from 0 all the way to 2. So the volume will be pi from 0 to 2, and the radius is just this piece right here, from the top minus the bottom, top minus the bottom. And in this case, it'll be 2 root x plus 3 squared, and our slices are dx. So let's go ahead and clean this up. We get the volume being pi, integral 0 to 2, and I'm going to change this to be 4 times x plus 3. What I did is the 2 squared and then the root x plus 3 squared dx. And let's go ahead and finish this off. So we have the volume equals, I'm going to take the 4 and the pi out in front, 0 to 2, x plus 3 dx. I'll integrate that. I'll get the volume equals 4 pi and 1/2 x squared plus 3x. When I integrate this on the bounds from 0 to 2, plug these in, you get the volume is 32 pi cubic units. Alright, let's move on to the second one. Second one says, find the volume of the solid that results when this region, x equals 0, y equals 0, y equals 2 is revolved about the y-axis. So pretty similar, but we're going about the y. A little different equation. I'll go ahead and graph this. This ends up looking somewhat like this. And when you put in 0, you'll come up here at 2. You come up over here 1, 2, 3, 4. It'll look something like this. And we are going to revolve this about the y. So we have to slice it up this way, so we'll have dy's. Perpendicular, remember, perpendicular to the axis of rotation. So we need dy in this, which means I need to solve this so that it is in terms of y. So let's go ahead and do this. I could square both sides. I'll get y squared equals 4 minus x. And quickly cleaning this up, you'll get x equals 4 minus y squared. So remember, the volume is the integral of the area, and the area we're dealing with is pi r squared because we're making a cylinder out of it, rotating it around. We need dy's. We're slicing it from here all the way up to that value there. So the volume will be from 0 to 2. We'll have a dy because we're slicing it perpendicular to the axis of rotation. And in this case, this is my radius that I'm looking at, and that's going to be 4 minus y squared, which was here, squared, and don't forget our pi. Pi r squared, and let's work this out. we get the volume equals pi from 0 to 2 of 16 minus 8y squared plus y to the fourth dy. I've chosen to do this one by hand, which is fine. Volume equals pi. I'm going to go ahead and integrate. I will get 16y minus 8 thirds y cubed plus, this will be 1/5 y to the fifth on the bounds from 0 to 2. Plug that in. You'll get 32 minus, real quick, it'll be 8 thirds times the 8 plus 1/5 times 32. And quickly cleaning this up, I've got my calculator here on the side. You'll get 256 pi over 15 cubic units when all is said and done. All right, moving on to the next one. Let's slide this up. This one, find the volume of solid that results when the region bounded by 7 minus x, y equals 7 minus x squared, x equals negative 2, x equals 2 is revolved about the x-axis. So we're back around the x-axis again. Let's go ahead and graph this. This time, this is going to look a little bit different. And when I put in these values, let's see. I will come up here when I put in 0. It'll come up all the way up to 7 right there. And we're going from negative 2 to positive 2. When I put this in, when I put a value of positive 2, I'll get 4. So 1, 2, 3, somewhere about here. And same thing on the other side. So it looks like this with a curved top. That is the shape we are looking at. And let's go ahead and rotate this about the x-axis. Volume is the integral of the area, as we all know. And my slices are going to be like this, perpendicular to the axis of rotation. So my slices will be dx. I'm slicing it from negative 2 all the way to 2. So the volume, and we have our pi r squared, is going to be pi from negative 2 to 2. And this will be, this is the radius right here. It's this top minus the bottom. And this will be 7 minus the x squared squared dx. And work this out. We'll get pi from negative 2 to 2. This will be 49 minus 14x squared plus x to the fourth dx. And after we integrate, we will get 49x minus 14 thirds x cubed plus 1/5 x to the fifth on the bounds from negative 2 to 2. All right, handy dandy calculator. 2012 pi over 15 cubic units. All right. Moving on to the next one. Let's see what we have. Find the volume of the solid that results in the region bounded by 6e to the negative 2x, y equals 6 plus 4x minus 2 to the x. All right. On this one, I'm going to tell you right away, for my classes right now, we have not taken derivatives or integrals of e, so you will need to just use the calculator on this. So I have not taught you that quite yet. So we'll just go ahead and use the calculator for this one. All right, so the first step is, let's see what we're looking at. When I graph this, this is going to be up here at 6. So let's use another color here. At 6, and you will get this as being your top curve. I use my calculator to help me graph this, and this being the bottom right here. So this is the y equals 6e to the negative 2x. This is the y equals 6 plus 4x minus 2x squared. If you do this on your calculator, make sure you play with your window a little bit to get these bounds in there. And we are going to take this thing and we're going to rotate it about down here, the line y equals negative 2. So right here, we're taking this graph and rotating it just like that. So what we're dealing with is 2 radii. So on this one, we definitely need a washer method. And remember, that's going to be my small radius. That's going to be my large radius. But then I need to subtract out this. So minus the line of rotation. In this case, minus the line of rotation, which will be y equals -2. So our larger radius is going to be, and remember, our slices are dx because we're going perpendicular to the axis of rotation. So our slices are dx from 0 all the way out, and this is at 1 right here. This is just to 1. From x equals 0 to 1, right here to there. So we're slicing it dx from 0 to 1. So I could set this up on the side. So I know that I'm going from 0 to 1. All right, so the big R, it's going to be this 6 plus 4x minus 2x. That's this. And then we have to subtract out this little extra because we're rotating down here. So this is minus -2. The little r is going to be the 6 e to the -2x minus the -2. So we can clean this up a little bit and say the big R ends up being 8 plus 4x minus 2x squared. The little r will be, I'll just leave it as 6e to the -2x plus the 2 like that. And that's what we're going to put in here. We have pi, because we're going around, times the big R squared minus the little r squared, dx, because our slices are perpendicular to the axis of rotation. So the volume is going to be 0 to 1, pi times the integral from 0 to 1. And let's go ahead and put these equations in. 8 plus 4x minus 2x squared. Squared, remember, it's the big R squared minus the little r squared. So you don't subtract them then square them. You have to take each of them separately. So this will be minus the 6e to the -2x plus 2 squared, and all of this dx. All right, so now I'm going to tell you at this point, we're going to go ahead and use our calculator to help us with this, and you will get the volume being 64.2556 pi cubic units. All right, let's move on to the next page. So let's go ahead and zoom in on this a little bit. We'll move this down. In fact, we could zoom in just a little bit more. All right, here we go. Find the volume of the solid of revolution generated by revolving the region bounded by y equals 1 minus x, y equals 0, and x equals 0 about the x-axis for part A. So let me go ahead and quickly sketch a graph of this here on the side so that we know what we're looking at. And when I do this, we will get this right here, where this is from 1 and 1, and it goes like this. It's linear. And we are taking this about the x-axis. This is pretty straightforward. This is our radius. We're slicing it perpendicular, so that's going to be our radius. We're going to use dx. Volume is the integral of the area, which is the pi r squared, as we've always said. And we're going slicing it from 0 all the way to 1 in the x. So the volume will be the integral pi times the integral from 0 to 1, and the radius is just 1 minus x quantity squared dx. And work this out. You will get, let's go ahead and FOIL this out. You get 1 minus 2x plus x squared dx. Volume, after we can integrate this, will be pi x minus x squared plus 1/3 x cubed. And plug everything in, you will get pi over 3 cubic units. This is on the bounds from 0 to 1, sorry. Okay, moving on. The y-axis, so it's the same thing, but this time we are taking this and going this way with it. Since we are going that direction, we need our slices perpendicular, so now we need dy, which means I have to take this y equals 1 minus x and put it in terms of y, so this will be x equals 1 minus y. Well, if you notice, this equation is pretty much the same as that one. So the volume should, since we're slicing from 0 to 1 again, but this time we're slicing it in the y, I mean, it sets up the same exact way. 1 minus y squared dy this time. So work all of it out, you're going to get the same exact thing, same exact answer. So 0 to 1, 1 minus 2y plus y squared dy pi y minus y squared plus 1/3 y cubed on the bounds from 0 to 1, and you get pi over 3 cubic units again. Pretty much the same equation. Let's work out the next one. On the next one, we've got the same thing again, but this time we are rotating, and I want you to be careful with this one, about the line y equals -1. Here's 1, there's 1. So we're taking this, and we are going to rotate it. We're going to rotate this. Here's -1 that way. Well, we need our slices to be dx, but look, this is a hollow part. This is empty right here. When I rotate this around, this is a washer. This will be the hole right in here as I rotate it around. So that's what you got to be careful with on this one. So we have to have an equation minus a line of rotation on this one. And we've got two different radii. We've got the larger radii from here to here minus our line of rotation, and the smaller one, which is just 0, to here. So the larger radii, the larger radius, I should say, is going to be this 1 minus x minus -1. So minus the line of rotation. So the larger radius in this case is going to be 2 minus x. The smaller radius is 0 minus -1. So this case it'll just be 1. Our volume will be pi, and we're slicing it from 0 to 1 in the x. So we have our dx's, and this time we've got this larger radius squared minus the smaller radius squared. So this is 2 minus x squared minus 1 squared times that dx. All right, we can work all this out. We get pi from 0 to 1. This will be 4 minus 4x squared plus x squared minus the 1 dx. So volume is pi from 0 to 1. This will be 3 minus 4x plus x squared. Actually, let me back that up again. Let me back that up. 3 minus... Okay, so it'll be 3 minus 4x. This is not a squared. That's where I saw something there. Okay, dx. And after we integrate, we'll have pi. And this will be 3x minus 2x squared plus 1/3 x cubed on the bounds from 0 to 1. Put your values in, you'll get pi, you'll get 3 minus 2 plus 1/3, which will give you 4 pi over 3 cubic units. All right, moving on to the last problem. Let's slide all this up. Find the volume of the solid whose base is bounded by the graphs of y equals x plus 1, y equals x squared minus 1, cross sections perpendicular to the axes are. Now, we forgot to put something in here, but I know what this should say. Perpendicular to the x-axis. Let's make it perpendicular to the x-axis. So let's go ahead and first start by graphing this real quick on the side. And we've got this x plus 1. That crosses over here up at 1, and over here at -1. So it's linear, goes like this. Then we've got this other piece. Let's draw this in a blue color so we don't get confused here. And then we've got this other piece that is a parabola and it's going x squared minus 1, so it's going to come down here at negative 1, and it'll come up here, and they will intersect up here at 3. So this will be at 2. When I put in 2, I'll get 3 for each of them, so they'll intersect here at 2 comma 3. So that's the region I'm looking at. And now for the first one here, I'm taking these to be squares. Okay, so what this means is there are squares coming out of the paper like this, coming out of the paper at you. So for a square, we have to find, when we're doing cross sections, we have to, and they're perpendicular to the x-axis, just the way I drew it right there. The area of a square is side squared. So remember, the volume is the integral of the area, and the area that I'm dealing with are these squares, so it's a side squared. Well, what's the length of the side? The side is going to be this top piece minus the bottom piece. So in this case, the top one is x plus 1 minus the x squared minus 1. So our side length right here, and this will be used pretty much for all these problems, is going to be this negative x squared plus x plus 2. So on this first one, so just keep that handy, because we'll be, let me see if I can, I have a highlighter tool here, which maybe I do, maybe I don't. We are going to highlight this and keep this handy, because we'll be referring to this length right here quite often in these problems. All right, so back up here, let's continue on. So we've got side squared, so this means I'm going to take this negative x squared plus x plus 2 squared. That's the area. So the volume is going to be from negative 1 to 2. Notice there's no pi here. We're not rotating anything. We're just finding these squares that are coming out of the paper. And it's going to be the negative x squared plus x plus 2 squared dx. You can work this out if you want to go ahead and FOIL it all out, or you can use your calculator at this point. I'm just going to go ahead and do that just to make this a little bit quicker in the video. And this comes out to be 8 1/10. So this will be cubic units. You can write it, if you wanted to, as 8.1. That's fine as well. All right, for the second one, we've got rectangles this time. And the rectangles each have a height of 1. So what's the area of a rectangle? It's length times width. Well, this length, we'll just call this our side, which we know, and we found that to be negative x squared plus x plus 2. Again, this was this top curve minus the bottom curve. That's the length of that times 1. Okay, so we can say, you could also say like the width times the height, call that the width, the height is 1. That'll work as well. All right, so cleaning all this up now, it's just going to give you this equation, times 1. So the volume will be the integral from negative 1 to 2 of this negative x squared plus x plus 2. This time there's no square on it because this is just the area. You can do this one by hand if you want, and this will be negative 1/3 x cubed plus 1/2 x squared plus 2x on the balance from negative 1 to 2, and when all is said and done, you will get a volume of 4.5 cubic units. All right, moving on to the next one. Let's take a look. This time we have got equilateral triangles. Okay, well, what's the area of a triangle? Well, it's 1/2 times the base times the height. Now, if you, in class, we developed the formula for equilateral triangles. We said it's √3/4 times the base squared. If you don't remember, it's because we called this, we'll call the base a side here, we'll just say s squared, okay? And this height, this will be equilateral, so that's 60. This will be 1/2 s. Remember your 60, 30, 90 triangles. And this will be √3 s, so √3/2, since this is 1/2. So √3/2 s. So the area is going to be 1/2 times the base, which we called s, times the height, which is root 3 over 2s. So that'll be root 3 over 4s squared. This is s, there's s, root 3 over 4. So that's where we come up with the formula for equilateral triangle. So the volume will be integral from -1 to 2 again. Now remember, these are triangles coming out at you this time. And they're equilateral triangles. And we'll have root 3 over 4 s. Remember, this was our s. That's why we did up top. That's the length from the top to the bottom. That's this side. So s squared negative x squared plus x plus 2 squared. So our volume is root 3 over 4. Now look, this should look familiar to you. We need a dx, sorry, I need a dx there. Our slices are perpendicular that way. This should look familiar because it's the same exact problem as right here. We got this answer as 8 1/10, and then we have this root 3 over 4 times it. So this is going to be root 3 over 4 times 81 over 10, which will give me 81 root 3 over 40 cubic units. Again, I didn't really need to do this part right here because, well, I've already done this problem. Right here, this problem has already been done right there. It's the same exact thing. All right, so let's take a look at the last one here. And on the last one, here's what we got. Semicircles. Well, if I have a semicircle, the area is 1/2 pi r squared. This right here is my radius. But what I have here, because these are semicircles coming out now, what I have here is a diameter. The diameter is this s that we know of, which is this negative x squared plus x plus 2. So I need half of it. So I need half of this negative x squared plus x plus 2. So the area ends up being 1/2 times pi times 1/2 of this negative x squared plus x plus 2, which will give me pi over 4. Be careful, not pi over 4 yet. Let's kind of undo that real quick. Let me square this. There's my radius, sorry. I need to square my radius. So this will give me 1/2 times pi times now the 1/4 negative x squared plus x plus 2 squared, just like that. So well, this becomes 1/8, so pi over 8 negative x squared plus x plus 2 squared. That's my area. The volume, we're going to integrate this now from -1 to 2, and you're going to get pi over 8 negative x squared plus x plus 2 squared. Put this out in front from -1 to 2, and this, we already know the answer. Again, it's this same answer, the 8 1/10 answer. So we end up with, sorry about that, we end up with this pi over 8 times the 81/10 from up above, so I'll get 81 pi over 80 cubic units. So that was it, and hopefully this review has helped. Go back, you can take a look at some of the things I did for the semicircles, equilateral triangles, and rectangles, so hopefully those will help you because those are the most common shapes that we're going to probably see. The squares, the equilateral triangles, and the semicircles for cross-sectional area. All right, good luck on your test coming up.